Hey everybody, it's Mr. N, and we are going to cover the average value of a function. Now, we've kind of already done this because I've asked you what is the average value and over the interval, over that time interval, and then you guys have just divided it by the time interval. So here we are, we're just going to add this onto our integral, and the average value of a function is 1 over b minus a times the integral from a to b of f of x dx. So basically, you have the integral, which is the area under the curve, and if you want the average, you just divide it by the two endpoints, okay, so the two bounds. So we can say, suppose you had some function f at any given point x. If you have a value for y, what would the average of all those random infinite points you choose be on the interval from a to b? So let's just do a couple examples. Find the average value for this on the interval from 1 to 3. So simply put, we would just say, here's my A, there's my B, right? So we've got the average value, F average, equals 1 over 3 minus 1 on the interval from 1 to 3 of x squared. So dx, so this would give me 1 over 2, and then here when I integrate this, I'm going to get 1/3 x cubed on the bounds from 1 to 3. So that'll give me 27, 9, so 1/2 times 9 minus 1. Oh, I'm sorry, 1/3. So that would give me 13 over 3, which would be the average. Just real quick explaining what this actually is telling us as well is, suppose I had this curve, this x squared curve, and the average came out to be 13 over 3, so that means 13 over 3 is equal to that x squared. That's where I'm trying to take a look at that. And so this x comes out to be 2.08. So at 2.08, comma, I plug it back in, I get 13 over 3, right? So right here at 2.08, this is 13 over 3. That's where, oops, yeah, I didn't graph it so good, but that's where that occurs. Okay, so that's the average value from 1 to 3. All right, now for the mean value theorem for integrals, here's how this impacts this. If f is continuous on AB, then there exists a number c in AB such that the average, we have this average value. So applying this to the mean value theorem states that our secant is going to be our tangent. So applying this, that means our average right here will be this f of c value. So I can break this apart like that. So it says that in AB, c must exist such that the area of a rectangle AEFB, which is the height FC, and width BC is equal to the area. So in other words, I am creating, where do I put this point so that as my function changes, where is this value C, this height that I'm looking for, so that the green area and the red area will be equal. So where along here can I put it so that then I draw the height? So suppose I did it right here, for example. Suppose I put C right here and came up and drew it like that. Then I'll get this shaded region and then the other shaded region like that. Would those be equal? And that's what I'm looking for, is where do I place that value C so that I get these two regions to be shaded equally? Because here is my f of c height, there's my b minus a, and there's the rectangle I made, and I'm cutting this up, okay? And where do I put this c point so that when I come up to the curve here, I'll get this region and this region to be the same. All right, so here's an example of how you would see MVT on an integral. And we've got determine c such that f of c is the average value on that. Okay, so over here, we're going to set this up. Let me change the pen color. And we're going to say, well, we need the average value, so this will be 1 over b minus a integral from, here's a, there's b, -1 to 2. and this is my f of x dx, and I need this to be f of c. So then I can put all these values in. So this is 1 over 2 minus negative 1, which would give me, I'm going to write it up right here, 1/3 times the integral from negative 1 to 2 of 5x to the 4th plus 2 dx equals my f of c. So I'll end up with 1/3, and this will be x to the 5th plus 2x on the bounds from negative 1 to 2 equals my f of c. And cleaning this up, I will get f of c equaling 13. But I don't want f of c, I want the actual c value. So that means 5x to the 4th plus 2 equals 13. That's what that's telling me. So 5x to the 4th equals 11. So x is going to be plus or minus the square root 11/5, but now I got to look at my bound right here. And this comes out to be plus or minus 1.21788. Well, when I look at my bounds, the negative is outside of it, so only positive 1.21788 is what c could be. It can't be the negative because it's not in these bounds. So always check those bounds. All right, that was it. Again, average value is pretty straightforward. Most of the time you'll just be asking, what is the average value from here to here? And they'll give you a table, and you'll have to subtract the two endpoints of your A and B region that they're asking for. And we'll do more of those examples in class, and you've seen them already, but we will do more. All right, so thanks for watching. Hit that like and subscribe button, and I'll see you guys in the next video.